I'd like to welcome you to this meeting of the Healthy Planet Action Coalition with Glenn Weinreb. It's a great pleasure to have Glenn join us to discuss his work on climate solutions. Glenn is director of the Manhattan 2 Project, a US nonprofit that studies the question, is it possible to solve the climate problem with a surge of research and development in key areas? And if so, what are those areas? Glenn has published more than 50 articles and 35 videos on this topic, and his website, aplantosavetheplanet.org, contains some details on that. So over to you, Glenn.
Oh, thank you. So I'm going to go ahead and do share screen. So the question that I'm going to talk about today is it possible for HPAC to solve the climate problem? And if so, how? Okay. And one possible approach is to identify a realistic plan and then communicate that plan. And notice we have the word realistic here. And one might ask, well, what does that mean? And there's different possibilities, but one is realistic refers to not expecting people to do things they're not going to do. And with economics, this could apply to consumers not expected to pay more money for green products. And with politics, this could apply to not expecting government policy to have much impact on global warming. Now, we can look at carbon dioxide emissions over the last 40 years or so and see that they're going up. We can do linear curve fit on this and see that they're going up about 1.5% per year. And one might ask, well, why are carbon dioxide emissions increasing? And I think there's two reasons. One is prisoner's dilemma in economics refers to this idea that consumers do not benefit by reducing their own emissions. Instead, they only benefit if the other 8 billion people on the planet act collectively. And so that's one reason why carbon dioxide emissions are going up. And then another is carbon dioxide emissions math. We have global GDP growth of 3% per year, and then we can reduce emissions by 1.5% a year doing with decarbonization activities and better efficiencies. And then we combine those two and we get the observed CO2 emissions growth. And so in theory, how do we deal with this? We can do R&D to drive down the cost of green energy so it costs less than fossil fuel, and then people would switch over to save money. And that could, in theory, entail a surge of R&D into fission, fusion, and geothermal. And then one might ask, well, how much money is that? Well, it could be billions of dollars to save trillions in climate-related costs. But also, we have another problem, which is the global warming problem, which is illustrated here, where the bathtubs represent radiative forcings in the climate model, where the bathtub on the left is excess carbon dioxide in atmosphere, and we have the carbon dioxide emissions problem shown with a faucet, which is where we put more water into the tub, and the global warming problem, which is the sum of the radiative forcings. So with the second problem, there's the question, how do we fix the second problem? One could argue reflect sunlight, but before we do reflecting of sunlight, even at 1/1000th of full-scale operations, one might consider that an experimental quantity, but before that, we need a surge of R&D in the primary methods of reflecting sunlight, which is stratospheric aerosol injection and marine cloud brightening, which are abbreviated MCB and SAI. So then you get to the question of what is a plan for reflecting sunlight? That is, in other words, what needs to be done between now and full-scale operations? And for an example plan, one might think of this as three phases: the R&D phase, the experimental operations phase, and the construction phase. So with R&D, you're doing two things. You're doing experiments, and also you're building equipment to run experimental operations. And this applies to both SAI and MCB. And I think the R&D phase is limited by money and as opposed to policy. And the reason is scientists can always find some nation to be supportive of doing experiments somewhere. And the experiments are tiny relative to what we do on a regular basis. An example is an airplane flies from New York to Tokyo and emits 1 million pounds of carbon dioxide into atmosphere. And that's just one flight with one airplane. And we have 28,000 commercial airplanes that are operating on a daily basis. So we're already putting all sorts of things into the atmosphere. So if a scientist is doing an experiment, then my view is the impact on the planet is negligible. But with experimental operations, I think at some point government starts to notice and they would assert themselves either in favor or against. And that's something you have to deal with. And then you've got construction phase, which is where you've got to build up your airplanes or your ships. And that costs money, and that costs government money. And then definitely government gets involved. And with reflectivity, there's 3 or 4 primary risks: harm, conflict, timing, and termination. Harm refers to the possibility that you see a harm while you're doing your experiments and building this up, and then need to reduce or stop. Conflict risk refers to the possibility that people fight over this in some way. Timing risk involves the possibility that we don't do these phases in the time needed. And termination risk refers to the idea that if you reflect sunlight for a long period of time and then stop reflecting, then you can get a surge of warming. An example would be if you reflect sunlight for 200 years and your concentration of carbon dioxide in atmosphere goes up to, let's say it's 1,200 parts per million instead of 400 parts per million, and then you stop reflecting sunlight, then your warming rate could be something like 3 degrees Celsius per decade in the first 10 years after you stop reflecting sunlight. Now that's, you can think of as an extreme case, but if you are reflecting sunlight and it goes on year after year after year, that's something that you have to deal with. So with reflectivity plan, there's examples of reflectivity plan out on the internet, and this is open source. So if somebody doesn't like these and they want to improve, they're welcome to take these for free and update in any way. So with HPAC, that original question is it possible with HPAC to solve the climate problem? And if so, how? Well, in theory, there's putting together a plan, let's say, that tackles the 2 problems, the carbon dioxide emissions problem and the global warming problem. And a group that works on this would have to think about what is their deliverables for their plan. And an example would be to have a reflectivity plan or multiple reflectivity plans, and also billion-dollar size proposals for reducing the cost of green energy and reflecting sunlight, where the proposals to reduce the cost of green energy are tackling, you think, as problem number 1, which is the carbon dioxide emissions problem, and the proposals for reflecting sunlight are tackling the second problem. Now, there's a website with examples of this type of documentation called plantosavetheplanet.org. And if one clicks or one goes to the homepage, there's examples of videos that summarize this kind of thing. And also in the menu bar, there's the Documents tab. And if someone clicks on that, they get to a web page that has billion-dollar size proposals, which are open source, which means they can be used in any way for free or edited or modified. And this is an example of one proposal is $1 billion for SAI experiments. And the prompt to the AI is, given $1 billion for SAI experiments over 5 years, what kind of experiments do you suggest they consider? And the AI puts together a list of ideas, and there's 13 shown here. And then the next question is, what are the various phases for each of these? And that's what's done first, what's done second, what's done third. The AI has suggestions for each. And then the next prompt is, what is a list of purchase orders for each phase? And the AI has a response for that. And then the next question is, who would receive purchase orders to do these things? And the AI has suggestions for people who do this kind of thing. And another question is, who might manage the purchase orders? And the AI has suggestions for who might do that. And another question is, what kind of requirements the funding source might have to protect their money. And the AI has suggestions that are things like there's independent review, and the people who develop, let's say, technology, and they take data and they have to place the information on the internet marked open source so it could be freely used by the scientific community. So there's various requirements suggested by the AI. And also you can ask the AI for the top papers that have been published that relate to these experiments. And also you can ask the AI for a list of panel members to be on a scientific advisory panel. For example, if you have a panel and there's the chair, the vice chair, and there's suggestions for people who have published papers on this area. So you have shown here are $5 billion size proposals for tackling the global warming problem put together by AI. And one question you might ask is, what kind of quality do you have here? And if these were worked on by top people, the quality would be better. Also, if you take the SAI proposals and they were, let's say, worked on by somebody who's read many SAI papers, let's say somebody's read dozens of SAI papers and they're a scientist and they work with AI, they could do a better job with this. And same thing with marine cloud brightening. If you have scientists that have have a lot of experience with this, they could probably do a better job with the AI. These were put together in about a day. So the quality level is, it is what it is, but it could, I think, be certainly improved. So that those proposals relate to the global warming problem, but also you have the carbon dioxide emissions problem. And then the question is, how do you deal with that? And this table, which was generated by AI, summarizes the cost to produce electrical power in China using different methods. And the first two rows show the cost to generate electrical power, let's say per unit electricity. Unit electricity is megawatt hour. And this is using nuclear power where you automate the site construction using custom machines. And you see these numbers, $30 or so, and that beats all the other options. And this is another way of saying that if you automate site construction of nuclear power plants, which are currently running, PWR in China, they've already made 35 of these, and they've got something called HTRPM, which is meltdown resistant, and this is running commercially. So these are already accepted, they're running commercially, and you can copy these and automate site construction and end up with electrical power that costs less than these other approaches. And solar power is shown here at the bottom of the table. It's at $44, which is pretty good. And if you have a coal-fired power plant, they're estimating the marginal cost, which is the cost to get another unit of electricity, assuming that the cost of the equipment has already been paid for. That's at $44 too. So China built 100 gigawatts of coal-fired power plants in 2025, which is a ridiculous amount. 1 gigawatt is a large nuclear reactor. So 100 gigawatts of coal-fired power plants is enormous. They also built 400 gigawatts of solar power in 2025, which is enormous. And this table corresponds to those numbers, meaning if these are the actual numbers, then they would explain why China did what they did with their 6% per year GDP growth. So the things that they're doing are, for the most part, explained by providing electricity at the lowest cost to the consumer. But if you want to change that, then consider automating the construction of nuclear power plants, and then they'd switch over. Okay, and then to do that, there's proposals that summarize how to do that, how to automate site construction at a nuclear power plant. So these are tackling the carbon dioxide emissions problem, whereas the other proposals are tackling the global warming problem. So if we go back to possible strategy for HPAC of, in theory, you can put together a plan of some kind and then communicate that. Then the question is, well, how do you communicate that? And one possibility is you have a conference, a climate moonshot conference, where you explore the question, is it possible to solve the climate problem with a surge of R&D in key areas? And if so, what are those areas and how much might a so-called moonshot cost? And a possible strategy for a conference is to expect climate change to cost trillions of dollars. Therefore, it is reasonable to spend billions of additional dollars on R&D to save trillions. Yet what might be developed, and each speaker at the conference could be allocated $1 billion over 5 years to solve a specific problem. And the combined efforts aim to bend the global warming curve so that Earth's temperature peaks and then drops back down. So there's a document on the internet that's a draft that describes a possible conference. And if somebody's putting on a conference, they have to decide who are the speakers, what are they talking about, etc. But that's one way of communicating plan. And another way of communicating plan is a movie that explains how to tackle the climate problem with a surge of R&D. And there's a screenplay that's being worked on, and it's currently about 80% done. And this is an excerpt from the screenplay where we have an 18-year-old college freshman. Her name's Nancy, and she's asking Professor Stone, is it possible for a few freshmen to solve the climate problem? If so, how? The professor says, you have more power than you know. And the freshman says, tell me about my secret power. And the professor says, billions to save trillions. And the freshman says, explain. And the professor says, we can spend billions of dollars on additional R&D to save trillions in climate-related costs. And the freshman says, but what might be developed that is not already being worked on? And the professor says, that's for you to identify. And the freshman says, but how? And then the professor says, you need your second secret power. And the freshman says, what is that? And the professor says, your campus. And then the freshman says, we can ask professors what they would do with billions of dollars for additional R&D and record the responses on a phone and feed that to AI and generate a summary document. And so that's an example of an excerpt, let's say, from a movie. And with a movie, somebody can work on a movie at many different levels. One is just a couple-page summary of a movie, and another is to work on a screenplay. And then the question is, what kind of quality do you have? And let's say your quality is half of what it needs to be for a major filmmaking studio to take interest in it. So maybe you've got, let's say, a first draft, which is, I don't know, half of what you need. And then in theory, professional filmmakers can improve it and get it to the point where it's accepted by large filmmaking studios. So that's something that can be worked on. So again, you've got, there's conference that can be worked on and film that can be worked on. And also, if you have a group working on solving the climate problem, there you get into the question of ask. Does that group want to ask for something? And these are examples of different things that one can ask for. If you're doing actual R&D and you spend $100 million, then you can do rough designs of machines and work on various models and work on proposals and things. And if you're doing plan development, and let's say you have 10 $1 billion proposals that have been generated by AI and you want to improve them, and you spend $100,000 to improve each of them, or you hire top people to work on them to edit and improve, then that may cost $1 million for plan development. And also with communications, if you have a moonshot conference and you have to hire people to work on their talks and travel, then you might end up spending $250,000 on a conference. And then if you hire, let's say, experienced movie making people to work on a film, to not produce the film, but just to work on developing it, that may be $250,000. And to produce an actual film may be $3 million. So if you have a group working on plans and communicating, and they have, let's say, an ask, then these are some kinds of things that could potentially be done. So the question for people at HPAC is there a group within HPAC that would like to develop a realistic plan for solving the climate problem? So I will open this up to questions. We have Sev Clark.
Yeah. Then the green energy is only about 20% of the carbon problem. How do you propose to address the other 80%?
So are you talking about, when you say carbon problem, you're talking about carbon dioxide emissions?
Carbon dioxide in the air.
So the excess carbon dioxide in atmosphere relative to 150 years ago, we have about 1 trillion tons. And that's due to past carbon dioxide emissions. So if you reduce future carbon dioxide emissions, you still have your past carbon dioxide emissions, and sunlight comes from the sun and travels through this excess carbon dioxide in atmosphere, hits the ground, and then you have heat radiation going back out, which is absorbed by this excess carbon dioxide in atmosphere, and that's a warming source. And then you also have other warming sources like methane in atmosphere. You have declining sea ice, you have thawing permafrost, and these are referred to as radiative forcings, and they sum together to get total radiative forcing, which is your global warming. And so reducing future carbon dioxide emissions has very little impact on global warming. And so in a sense, there's two problems, the carbon dioxide emissions problem and the global warming problem. So to tackle the global warming problem, you've got things like reflecting sunlight, which is SAI and MCB. You can also look at removing carbon dioxide from atmosphere. But if you remove, let's say, 10 billion tons per year out of the trillion tons, or like 1,100 billion, you got 1,100 billion excess. And let's say you remove 10 billion per year, and it costs $1,000 per, then that cost is $10 trillion a year. If you, let's say, reduce the cost to $400 per ton, then you're looking at $4 trillion a year. So these numbers are prohibitively expensive. So it's possible that stratospheric aerosol injection and marine cloud brightening, which are more affordable, are potentially needed to tackle the climate, for the warming problem. Okay, we have Robert.
Thanks. Just check, Seb, were you wanting to follow up with Glenn?
You haven't given any methods by which we might reduce the carbon dioxide in the air, or indeed the much in the way of 80% of the way of say natural emissions. I was wondering whether you had any preferred methods for that. I of course do, but this is not my presentation.
So the right. So as far as carbon dioxide removal, CDR, which is sometimes referred to as direct air capture, DAC, there's a couple of techniques that are being looked at. So an example is using alamine chemicals to pull carbon dioxide out of the atmosphere. Another method is ocean iron fertilization, which is where you put iron into ocean water, and then that promotes plankton growth, and the plankton absorb carbon dioxide, and then that falls into the deep ocean. And so that's another method. But there's an experiment that was done where they had a cone with a surface area. It's a cone that's underwater, like at a depth of 100 meters or so, and it's got a surface area at the top of about 1 square meter. And you have plankton falling into this cone, and then there's a tube at the bottom of the cone, and this is called a sediment trap. And you can see how much carbon ends up in that tube. You get a layer of carbon. You can quantify the amount of carbon that you get, let's say, per square meter of ocean water. And so they measured how much carbon you could potentially pull out of the atmosphere using this trick. And also, this is done where the conditions are favorable, which is where you're inside of an eddy, which is the water swirling around, and your water is high in silica and low in iron, and you have a certain species of plankton. And if you take the number of square meters in the ocean that are favorable and the amount of carbon that it appears we can pull out of the atmosphere and multiply the two numbers, then we get the maximum potential or an estimate of maximum potential of how much carbon we can pull out of the atmosphere using this technique? And the answer is it's not much relative to the size of the problem. So that's an example of a technique for pulling carbon dioxide out of atmosphere. And I think it's deserving of research. And there's a proposal that was put together by AI for a $25 million ocean iron fertilization research fund that's available for free out on the internet. But I don't know, based on past experiments, I don't see that solving the global warming problem.
Thanks, Steve. So, Glenn, I thought that your approach is superb, actually. I think you've got a really uniquely practical approach to global warming and climate stabilization. And so I really congratulate you for the rigor of the work that you've done. And I think it's really good that you've taken such a practical utilization of artificial intelligence. Like there's obviously a lot of public concern about AI, and you're providing an example of a use of AI, how humans can cooperate with the machines to improve our thinking. So I'd just like you to elaborate on how you see the use of artificial intelligence to solve the climate problem.
Well, I'll tell you, the AI is absolutely tremendous, and I am as amazed at the things that it can do. And so I think the question is, well, how do you use the AI to solve the climate problem? Like, what kind of things can we, what kind of prompts can we put into the AI? And so I think, in the right hands, with the right prompts, I think it can do amazing things.
Yeah, I agree. I would like to follow up. Just you've titled your presentation how HPAC can solve the climate problem, and like obviously HPAC is a tiny organisation with no money or influence, very limited, and so there's a challenge for us to work out how we can collaborate with other organisations to build the constituencies of support and raise the funds for promoting the sort of proposals that you're talking about. And I think a further issue is the whole legitimacy and permission and advocacy agenda. That the sort of ideas that you've presented in your presentation are immensely controversial. There's a lot of people who are very skeptical about the ideas that you've presented, and so I'm interested in your thoughts on those problems.
Right. So geoengineering is controversial. A lot of people don't like it, and also that's softening. And there's an interesting graph that shows the flux of water through the Atlantic Ocean currents and how that's changed over the last 15 years. And it shows it coming down. And so that, is something that is, of concern to the British. And about a year ago, they awarded 56 million pounds of British pounds of funding for geoengineering research, and driven in part by concern over declining ocean currents. And if you lose ocean currents and the water is colder, a couple of things happen. One of which it gets colder, but also you have less rainfall, and then you end up with less food production per acre. And the Europeans are concerned about this. So as evidence of this, grows, they become more concerned about climate change and more inclined to consider geoengineering and support geoengineering R&D. And also the Chinese are concerned about their rivers that feed agriculture and also are used for transportation of materials into factories and out of factories. And so they're concerned. So I think the concern goes up, and then support for research goes up. But also, before you do, let's say, experimental operations of 1/1000th of full scale, which is, you could think of it as a tiny amount, but before you do that, you've got to develop the equipment to do that. That could take 3, 4, 5 years to develop the equipment to do that. So that's airplanes that move material into the upper atmosphere. It's monitoring systems. It's all sorts of software, and it could be a $1 billion type of thing to support, let's say, R&D before experimental operations. And we define beginning experimental operations as 1/1000th of total, which so then the question is, do you have a maverick scientist out there and a funding source that's willing to push that forward? And maverick meaning they're willing to go anywhere in the world to run their experiments, or they find a collaborator in a nation that's supportive, and they find ways of pushing forward. And when I was in high school, I worked in a research laboratory at the University of Virginia, and the professor there was an example of a maverick scientist, and he had a temper. It was a terrible temper. And one of the things he would do is, if he was on the phone with an administrator and the administrator was giving him a hard time, he'd have a temper tantrum. He'd take the phone, bolt it to the wall, and he'd tear it off the wall and throw it across the room. And I know this sounds crazy, but this is the lab that I worked in. And one of my jobs was to fix the phone. So I had a drawer of phone components. So, if the wires are broken or something, that was part of my job, was to fix the phone. The graduate students loved this guy because he could get things done. And the administrators were scared to death of him. And he had the support of the chair of the department, which was, as far as he was concerned, that's all he needed to continue doing what he was doing. And then he eventually moved to the University of Washington, where I heard he was bringing in more money than any other professor because he was so productive. But not that I'm advocating that anybody tear a phone off the wall, but the point is, there's professors out there that are inclined to get things done. And so with SAI, I think you take that and money and nations that are supportive, and I think you can do R&D and without anybody noticing. And again, one airplane could put 1 million pounds of sulfur dioxide into the atmosphere. So an experiment, nobody's going to notice an experiment. But also you've got, at some point, if you're running experimental operations at 1/1000th or some small level, and that corresponds to, let's say, a large airplane, a Boeing 777 that can seat 400 people. And let's say it's modified as a freighter and it's modified to move 100 tons of sulfur dioxide into the atmosphere, and you have 100 flights or so, that would be approximately 1/1000th of full-scale operations. That would start to get noticed. Okay, so the scientists out in a boat or out in an airplane could do things without anybody noticing, but 100 flights of a big airplane, then that would be noticed. And then you have governments that would start to assert themselves, and people start to assert themselves. But again, you've got, I think, 5 years of R&D or so before that point.
Let's go to Aria.
Hey, hi. Glenn, thank you. I mean, I feel like you've got such a big vision, and the fact that you're bringing that big vision to us, that's the kind of energy that can help get things done. So thank you for that. Some things popped into my head when you were presenting, a few things. I just wanted to, give you some feedback on some things. One is, there are concerns about a sense of being overly technological when it comes to solving a problem that's, so multidimensional. And there's so many different approaches that can be utilized. So one of the things I was thinking about is a potential partnership, for instance, with Paul Hawken and the regeneration work that he's doing. I mean, I feel like right now, last time I went to their website, it's very robust in using nature-based solutions to draw down carbon dioxide, help restore our ecosystems. And that kind of collaboration would also help increase the buy-in of the general public and, help make this feel more palatable while also, I think, giving more of a, complete sort of planet-friendly approach as much as possible to the plan. So that was the first thing I wanted to share that popped up into my mind. But also,
Aria, let's take
yes,
let's just take that, and then you come back for a second one, if that's
yeah,
okay.
definitely.
Glenn, have you got any comment on Aria's?
Oh, sure.
question?
Yeah, I think let's say you have a group of people that are putting together a plan, and they have to decide, what is the deliverable? What do they want to produce? And they got some documents of some kind, and I don't know what the deliverable is, but the group would decide. And also they have to think about their asks, and also they have to think about who do they want to reach out to help them. And an example would be, let's say there's a document for a proposal on a certain thing, and let's say there's some experts in that field, and they may want to request that they help with editing and improving the documents. So at another organization, they may have some people that can help in certain areas. And also with an ask, let's say a group has an ask, let's say it's a climate conference of some kind or a climate moonshot conference of some kind, they could in theory collaborate with other groups where they work together to set up speakers and also promote the conference. So collaborations could certainly be done.
Yeah. The other thing I was thinking about is, I know there was recently an email circulated about the publication for the risk framework. And I just think that would probably, including that in the framing as this is developed, I think could potentially really help strengthen the argument of why this would be needed. So I wanted to add that thought. And then as far as the film is concerned, I know you and I have had some conversations about that. Certainly getting it in the right format. As you know, I've been working on my TV series for a long time, took a lot of classes to feel like I was able to flesh it out and make it something that felt like industry standard. So that's going to be really important, I think. I mean, unless you've got someone who's just really in the game and ready to do that for you. So just keep that in mind. And I'd love to share Revolution Earth with the group soon as well. Yeah.
Okay. Yeah. As far as the film project, so I've been working on a screenplay for a film, and the draft is on the internet. Anybody is welcome to look at it and comment. It's 80% done, and you have professional filmmaking studios like Amazon, MGM, and Netflix studios, and DreamWorks and Paramount, and they have a certain quality they're looking for. And my quality is less than what they're looking for. So you think of it as a gap between where I am and what they're looking for. And then the question is, how do you move, across the gap? So I think I would need help from people with professional filmmaking experience to take what I have and improve it. Also, somebody could take what I have and put together a variation of this. I have 18-year-old college freshmen finding out how to solve the climate problem with R&D in a personal journey. But in theory, instead, you could have a documentary where you have somebody like a Michael Moore type who wanders around and talks to people. And so you could have a narrator of a documentary. That's another format, but that's another approach. And so then the question is, like, given what I've done, is somebody, can this be improved? I think so. Are there variations of this idea? Sure. And then you've got to think about, okay, is this an independent film, or are you working with a major studio? And I'm not sure. So there's all sorts of possibilities for where this project goes forward.
It's got a great framework and concept in order to tell the story, though. I think it's got some good,
Okay,
Yeah.
thanks a lot, Aria. And I'd just like to give a shout out for your our conversation with Mia, with the Mirrors for Enhanced Earth's Reflectivity team, and I put a link to that into the HPAC email list, and I thought it was superb. So well done, Aria. You really bring some really great ideas and passion into this whole question. We'll hand on to Mike McCracken.
Thank you.
Hi, Glenn. So I wanted to focus and look at on the science part of what you were saying about what experiments could be done. And I guess I have a basic structural problem with how you've assembled it there, because I think what has to be done is first describe what the baseline conditions are and what baseline knowledge we have. And it didn't seem that AI took any recognition at all of what we already know. And then what you want to do is determine if you can do experiments that are going to lead to better knowledge. And you want to know then if that better knowledge is going to make any difference in the ultimate answer, so that if the experiment is worthwhile or not. And we know an awful lot about some of these aspects. And it just seemed that, there need to be a different set of questions asked to AI to do it. I mean, there is the question of whether these experiments are possible, and I've written some notes about my thoughts on it, in your plan that I've sent you. But I think the structure is more the problem with it. That it's there's an awful lot of knowledge about doing some of these things that go back to study in the stratosphere when we were talking about supersonic transport fleets in the 70s. There's just an awful lot of knowledge about some of these things that it doesn't seem get picked up in the set of outlines that you have. And then doing experiments to figure out which particular thing is going to make a difference and make for better knowledge. I guess I've been expressing the view that I'm not sure there are any of those. I've been listening to them, people propose experiments out there, but I mean, the notion that you can do micro experiments and very small experiments up there, the atmosphere disperses stuff awfully rapidly. What I missed was learning from what's been happening when there have been volcanic eruptions in the past, going back and analyzing and seeing what are the strengths and weaknesses of that, and of linking and comparing to models. What is it going to make, where are the discrepancies between model treatments of volcanic eruption debris, for example, or fire smoke debris now, compared to what observations are? Are there major differences? And then maybe you want to try and figure out what those are or something and focus. So it seemed like SAI just wasn't quite given the right questions or something. It wasn't going to quite approach. And you did it in a day, so that's amazing. But, I think it's going to take a lot of work to figure out what would be worthwhile experiments to actually do.
Okay. So, so let's say the quality level, where it is. Now, my training is I'm an electrical engineer. I have a 4-year degree in electrical engineering. So I'm not a PhD. I'm not a scientist. I'm not a climate scientist. And it's one day with AI. So the quality is where it is. And then you could ask the question, well, can it be improved? I would imagine so. I would hope so. And then another question is, well, who might work on that? Well, if you've got, let's say, SAI, for example, and you've got a scientist that has read many of the SAI papers, and one of the things that the AI did is it summarized what they considered the top 25 SAI papers. But let's say somebody's read many SAI papers, they're a scientist, they understand them, then that person with AI could probably do a better job than what we have here. And maybe instead of spending 1 day, they spend 3 days. I don't know how much time, but in theory, I think things can be improved. Also, if anybody wants to go on Zoom with myself and talk about some of the things that have been done with the AI, and I have other AI conversations that we can look at, and also we could talk about what kind of prompts could go into the AI. Anybody wants to work on that? I don't know if I'm a particularly good person to work on that, but I am available to chat on Zoom about AI prompts and how to work with the AI.
Yeah, I mean, I think the real challenge is the second part of what you say, is communicating and figuring out what information is it that would give people more confidence and lead the public to do something. That seems to me to be the real challenge that we just don't know. What is it gonna? Is it gonna just? We're just gonna have to wait for disasters to happen and people say they have to do something, or is there a chance of actually communicating with people and get them to do something in advance?
Well, so there's three tools in the toolbox, so to speak. There's reducing carbon dioxide emissions. You've got carbon dioxide removal, removing carbon dioxide from atmosphere, and then you have reflecting sunlight. Those are the three big tools. And in theory, if you have a global climate model which is accurate, we don't have a global climate model that's accurate, but if we did, and we put a website user interface on top of that, and then at the website, we have the website user specifies an objective, like they want to bend the global warming curve or they want to prevent the collapse of Atlantic ocean currents, then in theory, the website using an accurate climate model could predict things like how much sunlight needs to be reflected back into outer space to achieve the stated objectives. Now, we don't have that website, but if we did have the website, which requires an accurate global climate model, that's one thing that would be helpful. Another question is, does anybody trust the website? But right now, global climate models are not predicting what we observe. So we observe a certain warming rate, we observe a certain average global temperature, and the climate models have expected or predicted us to see less. So this tells us the climate models are incomplete. And then the question is, okay, what experiments can we do to improve our accuracy of the climate models? And there's two big areas that we know we don't understand. One is how much sunlight reflects off of air pollutions, which is another way of saying we need to measure the radiative forcing from anthropogenic aerosols. We know we don't know that. And so we have an estimated value with a big error bar. And so that's one area that needs experimental work. And then another is clouds. We know we're having trouble understanding clouds, and clouds seem to be changing a lot more than expected. And
if you take that from me, though, about resolving all uncertainties before we do something, we'll never get anything done. There's a real question if that's the right framing to be using. And I mean, it's really a comparative risk analysis that one has to do, and you're going to have uncertainties. That's the way the world is. People have to make decisions with uncertainties. I'm sorry.
Thanks, Mike. We'll move on to we've got three others who've got their hands up, and I think Greg Slater was the first. So I'll invite Greg to.
Here's the question: are we wrapping up in 11 minutes? Is that?
No, we go on for 90 minutes.
So okay, all right. So
is that okay with you, Glenn?
No, that's fine. I wasn't sure if we had to pace ourselves with the next three, but no,
of course,
we're fine.
No, my mistake. I should have said.
All right.
Said
Thank you.
Okay.
All right. Thanks. First, Glenn, thanks for presenting this, and I've heard other versions of it, and it's a lot of work and very impressive effort. I would just say a couple things about the scope of your effort, and you use the terms moonshot and Manhattan Project. One thing that I have a difference of opinion on is the vastness of the scope, which covers basically the whole climate spectrum. And if you look at the moonshot, the Apollo program, and you look at the Manhattan program, these were extremely narrow goals. And they were not broad at all. And particularly the Apollo program, get a guy to the moon, bring him back alive. And anything that contributed to that extremely narrow goal was done in the most efficient way possible. And nothing else it wasn't, let's go to Mars, so let's start thinking about Mars. Also, the Manhattan Project, again, we wanted to make an atom bomb. That was very narrow. So in the case of global warming, as far as I'm concerned, I mean, the narrow goal is to cool as fast as we can. That's the goal that I'm interested in pushing. And all of the other things are farther out. And fusion reactors, even automation of nuclear reactors, which is a great thing. And there are people working on that. And there was just an announcement about a U.S. company that is ready to supposedly do a production line of nuclear reactors, fission reactors. That's great. All these things are great. It's just that For me, all I'm interested in is cooling the Earth by whatever mechanism. Whoever can do it, that's what I'm for them. And beyond that, all of the mitigation, all of the CO2 well, not anything that doesn't move toward actual cooling. Now, so I'll say one more thing, and that's that for me, because this is my narrow goal, what I want to get to is I want to get to where we actually are pushing against people actually pushing back. Right now, there's nobody actually pushing back. We've never tested it. I mean, so Make Sunsets has demonstrated that you can put a thimbleful up time after time, and they aren't executed, imprisoned, and they're doing it. So the world doesn't care about whether you put a thimbleful at a time. So what if you put a kiloton up? Is that when you cause a thermonuclear war or vast war? I think that's malarkey. But my goal is to get.
Let's just wind
okay,
up.
but my goal is to get to the actual opposition point as fast as possible, and therefore do unauthorized tests or unauthorized deployment of as much as you can, as fast as you can in the open ocean, without involving and then see what happens. That's the experiment, is to find out what happens with societies, and that's more the experiment than Mike's experiment to what do we learn about microphysics. My experiment, what do you learn about society's reaction? I want to get to that point after 50 years, which we haven't gotten to. Anyway, you may respond to both the focus question and my strategy.
So I think there's all sorts of things that can be done, and with experiments, there's different types of experiments, but one of which is, in theory, you can put sulfur-based aerosols into the atmosphere with an airplane and create a plume. And then you can have an airplane fly above the plume and then look down with an optical telescope, and you can fly through the plume and then take direct samples of the aerosol. And then when you create your aerosol, there's different parameters that you can vary. There's the concentration of aerosol in atmosphere, and there's the size of the droplets, and there's the ratio of water to H2SO4 liquid. Anyway, there's things that can vary. And
Glenn, I'm at the risk of being, I've actually hypothesized and set up parameters for such experiment. I understand the experiments. To me, there are so many experiments you could. I don't care which experiment you do. There's 100 experiments you could do. The more important is getting volume in the stratosphere to normalize the actual any kind of experimentation. And everybody's approach so far is get a universal agreement. I'm saying just do it and find out where you hit the wall with societal willingness. So I don't need to learn which kinds of experiment can be done. I've looked at this intensively, and I think everyone here knows the basic experiments you can do. Now, Mike thinks they're all useless. I totally disagree with him, but the point is, the experiments you're mentioning, we know those. I'm not saying, I'm not asking for a list. I'm saying the strategy that I'm advocating is just do any experiment and provoke. I want to provoke a response, because people are saying it's instantaneously global thermonuclear war or whatever, and I'm saying that's just horse pucky.
Right. Let's move on.
Okay. So there's a couple of different strategies. So if you've got a scientist that's conducting experiments, then I think they're limited by money. If you've got a funding source and somebody feisty like Gregory Slater, Professor Slater, I think you could have experiments that are done, and I think that would be helpful. Then one question is, do you do it quietly or is somebody in a fighting mood? And that's up to the professor as to whether they want to be quiet, not tell anybody, or they want to tell everybody and go out and argue.
Well, I'm in favor of absolute transparency, just not waiting for authorization. And I'm not interested in fighting. I'm just interested in dumping.
Okay, and there's the experimentation, but then after that, and you've got to develop the equipment to run the experiments. Then you run the experiments, and it could be a couple of years of that. And at some point, you're at experimental operations where you're at maybe 1/1000th of total of
I'm talking scale. About one kiloton on one plane, one experiment. You analyze it. You would censor it. You analyze it. You don't need 100 professors. One
Right.
person can do it with AIs.
Okay, so let's say that what you just described is experimentation. So
That's
I'm in
experiment
favor of
one.
that.
That's experiment
All
one. Let's get experiment
right.
one under our belt.
Greg, we're going
That
to move
that's
on to the next people who've got questions.
Yes. Yeah, sure. Thanks.
Wanted to comment that I think that what your comments illustrate is the priority of permissions and legitimacy and politics and the public debate around this whole space, and it's something that Aria raised as well around uh, uh, the conversation and so on. So we'll move on, and we've got Ron and Robert and Marshall. So Ron, can I ask you to be concise, please?
You're, okay. Thank you. Thank you, Glenn. Thank you, Robert. So let me try and be concise somewhat. The problem is what I hear, Glenn. You're admirably energetic on this. I think it really is admirable how much energy and effort you're constantly putting into this. And that's something we need. We need people speaking out and saying we need to do something. So that's good. Uh, where I part ways, and you know some of this, we've had this discussion. I mean, fission nuclear power, there are political problems with that. It creates, we know the problems. I mean, now Iran wants nuclear power. All these, Saudi Arabia wants nuclear power. What do we do when every country in the world can basically, destroy the world or destroy a good part of it? This is a huge problem. So the political dimension of these things needs to be considered. These are not just purely technological issues. With regard to the topic at hand, the cooling thing, I think my view is and I think my understanding is many people in HPAC would agree, is we are in a not a risk, but a risk. The risk is on the side of, we're going to burn up if we continue on this path. So the risk is actually on the other side. It's continuing to do as we do right now is the huge risk, and the risk of not trying to cool right away. That's the big risk. And it's not risk. It's risk just on the other side. And so, in terms of the political dimension, I think it's really important to try and push the Overton window where we think it might be feasible. And so, doing an initial testing and deployment. And that's one thing I'm a little, I'm always wondering, are you advocating pure research, or are you actually advocating that we do a pilot, a testing and pilot? And I kind of, I think, I'm not a climate scientist, so I tend to, I think, if Mike is correct,
Hey,
and
Rob,
I'm
there's a
sort of,
couple of questions there
then
already.
the
You've
testing
got,
is the
you've
testing
got,
just in the stratosphere, it just spreads out. So
yeah,
those are the three questions. And if
nuclear risk, and what was the last one?
It's
yeah, so
risk,
you
not
have
risk.
Yeah.
It's a third kind of risk problem, and the third one is Glenn Weintraub's position that we need to go around trying to get $1 billion or whatever it is for research, or are you actually trying to push the Overton window and say, no, what we need now is some kind of testing and piloting, actual practical, like work in the polls, as many of us have suggested,
Thanks,
to get this started, yeah, on a local level.
so okay, so if you can look at like what limits what happens if you have a high net worth individual gets on the phone with Professor Slater and says, I want to put a kiloton of sulfur dioxide into the stratosphere. I think they could get it done. And one of the things it asks is what nation would support flying airplanes from their soil. And okay, after they figure that out, I think they could get it done given money. And also, they may not advertise on a website what they're doing, because unless they're in a fighting mood and they want to argue with people. But if they don't want to do that, they just want to get things done, they may not put this on a website, but I think they could get it done. But also, I think at some point, you have governments that start to assert themselves. And I think they could probably move forward without a government fussing at them, because I don't think they would notice. And also, um, uh, already we're putting a lot of material into the atmosphere. So a kiloton may sound like a lot,
So,
but it's not that much relative to other things. So I think they could get away with that. But at some point, you have the great powers of the world that start to notice. And I don't know what that point is. Is that 10 kilotons or 100 kilotons, but something? And then they start to assert themselves. And let's
Well,
say
that's
you're
the
working with
experiment. I want to find out where that point is,
So-
Glenn, as fast as
so
we
well,
can.
so you start with something and you keep going, and at some point, people start to fuss,
so,
and
so
you see what
Glenn,
happens.
I mean, are you done? I'm sorry, Ed.
Sure,
Yeah, so
sure, I'm done.
I am very much in the urgency, corner here. We need to do something, however it's done, whoever does it. If it results in cooling the planet, we all benefit, hopefully. But if it is some kind of a, thing that just provokes a huge reaction and is not transparent or what, I mean, we do have to be a little bit careful about this. So that's where I think, the real important job is to try and open up the window, open up that window a little bit more so we can, I mean, if somebody is going to go do this anyway, then, hopefully they will do it well, and God help them and help us and save us all. But, that is what we're trying to do, is trying to start doing this in a responsible way, which is to start small, to gradually increase, to start in the poles and gradually increase, that kind of thing, and use all kinds of other methods. There's methane, there's the IMO stuff. There's all kinds of other ways to get a little bit of cooling that would also be helpful. So all of this is part of the political and social effort that I think we all need to take. And if we just talk about, I need $1 billion and I'll do a moonshot or something, people will, I mean, you can see how that can get people quite antsy, especially in this day and age where we've got certain billionaires that are,
Yeah, you need the story. You
on that
need
track.
you
Yeah.
need the piece of support.
So-
So politics is in place. Glenn, I think what we'll do is we'll move on to Robert Chris, if that's okay.
Okay.
Right, fine. Interesting discussion. I've got a lot of questions. I'm going to ask one. Over the last 40 years, one of the determining aspects of the whole climate debate has been the role played by the fossil fuel sector, which has generally been uncooperative and unhelpful in all moves intended to resolve this problem, because basically they want to carry on selling as much oil as they can. And they are the beneficiaries of vast amounts of subsidies from governments across the world. They are able, particularly in the States, but it also applies elsewhere, particularly in petrostates, to suborn the political system by vast amounts of political contribution to individuals there. So I'm really interested to hear from you, Glenn, how you think a plan from HPAC or whoever that is intended to address the issues that you've so eloquently discussed this evening, how do you think that the fossil fuel sector is going to react to this? Is it going to be supportive? Is it going to try and undermine it? Is it going to sit on the side? Are they going to be beneficiaries? Are they going to see themselves as threatened? What role do you think they're going to play?
So I started a business while I was in college. It was like 40 years ago, that designs and manufactures computer hardware and software products that automate research laboratories, factories, as well as all sorts of equipment used by the oil industry. And I've sold a lot of products to the oil industry, and I spent a lot of time talking to engineers in the oil industry. And they all know about global warming and carbon dioxide. And they also say things like, oil's not going to be around forever. And, you ask them why, and they're like, well, we're drilling in a certain location in Texas, and we know what the reserves are, and we know what the rate is of extraction, and it's going to run out eventually, et cetera. And so they all have this idea that in their career, they have to adapt to changes. It could be global warming, it could be reserves run out, et cetera. And they're decent people. And also, when I was in school, I took 3 courses in economics, and one thing that they taught is production follows demand, which is another way of saying you have a certain demand for a certain number of barrels of oil that are needed in the world, and then the producers will fill demand. And so you can fuss at the producers, but that's not going to do any good, because if you, let's say, drive up the cost, let's say for one producer, then other producers will move in. And so it's the demand for oil that is driving the producers. That comes first. And if you want to, let's say, reduce consumption of oil, an economist would say, well, you just got to get the green option to cost less than the fossil fuel-based option. That's it. That's all you have to do. And then the question is, well, what is the cost structure for your, let's say, nuclear power? How much do things cost? And in the United States, we built 2 nuclear power plants the last 30 years, and we had 10,000 people or so doing very little work for many years. And this drove up the cost dramatically. And there's no reason for that. But so we should be able to get the cost of green energy to be less than that of fossil fuel. And then people would switch over to save money. And so my view is it doesn't do any good to fuss or complain about the fossil fuel industry. And all we need to do is we want the green option to cost less than the fossil fuel-based option.
Okay, fine. That's a good answer. All I would say in response is dream on. I think that that's a fundamentally flawed analysis, but that's fine. If that's your view, that's what I wanted to elicit.
Okay, thanks, Robert. We'll invite Marshall Mermel to speak.
Thank you very much. Glenn, I'm sorry, apologies. Glenn, I thought your presentation was well done. I just want to share something very short and sweet to you, something that my father shared with me when I was a young lad. He was an inventor. He invented the thermal barrier window, the brake system for the Shelby Mustang, had 100 patents. And during World War II, he invented a lot of things that saved people's lives. He told me when I was 8 years old, he said, son, you don't know what you don't know. And I said, Dad, what does that mean? And he says, it means 3 things. 1, people are going to tell you you can't do it. Ignore them and go out and do it. 2, when you collaborate with others, as we try to collaborate with each other here, always ask the most fundamental question that has to be asked. And I said, well, there's got to be a lot of questions. And he said, there's one. And that question allows you to break through the psychological barriers and probably even the political barriers. That question is, what do we together need to know to succeed? Not to fail, but to succeed. And then the third point he made is, don't worry about the money. You'll make money, but always engage with people who have the right moral compass. If you don't, then you're dealing with Hitler. You're dealing with insanity. You're dealing with people who are going to, like the oil companies. I'm dealing with the oil companies right now. I have 30 joint ventures. I'm getting funding through a European Union climate bond. The first climate bond is a little under $1 billion, 840 million euros. How do I do it? It's because we ask those questions and approach. I'm more than happy to collaborate with you folks. I haven't been involved in HPAC for quite some time, but I'm telling you, it's all tied together. And Glenn, your approach is the right approach. You have to engage. You have to do it. And I think it was Ron or somebody here, Robert, that said, are you doing an experiment or are you doing prototyping? You need to ask the question, what do we need to know to succeed? With us, when we ask that question, we need to know. Some of those questions refer to how do you deal with countries like in Africa that we're dealing with, Nigeria, Ogoniland. There is more oil spilled in Ogoniland than you would believe, and we're cleaning it up. The point is, there is a way to do it if you keep your mind open and you engage with people with the right moral compass. I'll leave it at that. There's more things to do, but I'll leave it at that.
Okay. So so Marshall expressed a willingness to get involved in some way, right? So one thing we could possibly do is have another meeting with Marshall and myself and any parties of the willing to talk about next steps and what might be a reasonable path forward. I don't know if there's anybody who's interested in that, but I'm available. I don't know, Marshall, are you interested in such a
I'm
thing?
definitely, this is what we are doing. Our mission is not the tools that we bring to the table. The one analogy I'll bring, you don't go to the doctor and say, oh, open me up, give me triple bypass surgery. Nobody does that. You go to the doctor and say, I'm not feeling well. And if it's a cardiac event, does he need a stent or she need a stent? Do they need triple bypass, single bypass, or do they just need a better diet and exercise to get cured? The issue is you need an approach. We're engaged in this approach already. Our mission with our team is climate restoration and climate repair. That's the big mission. The tools that we bring to the table, like you indicated, they can be agnostic. We have our own technology. We have 40 patents plus trade secrets, but that's not the point. We will use other people's technologies and tools, and we can bring the funding. I'm suggesting that you just have to ask the appropriate question. What do we need to know to succeed? Work with people who have the right moral compass, and it will happen. It happened during World War II with my father, and it can happen again right now with this crisis that we're in.
Okay. So I guess, there's a question, is there anybody who would like to talk more on Zoom about some of the more details? And Marshall, are you interested in that, or is that?
Absolutely.
Look,
I'll participate. I'll make the time for it because we're doing it.
And
Okay.
and we can do that in the context of HPAC as well. So we can.
Yes. I belong to HPAC. I just haven't been involved in a long time.
Yeah.
So we could invite anybody to a meeting, and we could talk about what kind of things could be done, let's say, in putting together a plan of some kind with some type of documentation, and would have to think about, like, what are the deliverables, what kind of documentation are we trying to produce, or what are we doing, and we could see where that goes. And then we could invite the HPAC community. Anybody who's interested in this would be welcome to attend. Now, Gregory Slater has ideas for 1 trillion or 1,000 tons of carbon dioxide or of sulfur dioxide experiments. So he may be interested in something like that too.
I'll just say out loud, I mean, in principle, I'm interested. The problem is, I think my basic approach is different, but I'm interested in, I'm willing to participate. Also, let me just say that since Marshall mentioned that he's running $1 billion operation, I really am interested in hearing what he's rolling out and at what rate, because for me, it's the rollout of anything. It's an important thing. So if he's willing to provide information on his efforts, I'd be interested to know, because he's got more money than anybody I know in this range, other than people who are not really cooling people. So I'm very interested in that. But yeah, Glenn, I'm interested in talking. I just have to warn you that my approach seems to be quite at odds with yours, but I'm interested in talking. Yeah, so I'll say that. Marshall may not be done, but if I can say a couple comments, I was waiting, but Robert's was running the show, so yeah, can I go? So you mentioned just about the fossil fuel industry. I mean, it's true. Demand is there for energy. I think that the problem with the fossil fuel industry over the last, 40 years anyway, is they have actively obstructed by controlling governments. And so that's not the market working. That's options being eliminated or prevented by the fossil fuel industry. I don't exempt me or anybody. I mean, I think any of us could probably cut our fossil fuel generation by half if we were hardcore about it. We'd cut our consumption rate of all of our high consumption living. That could be done. Nobody's going to do that. And the third world, or whatever it's called, is right at the point where they can start increasing their consumption, and they're not going to say, oh, I'll stay poor just so we can do this. So there's huge demand. You're right. But there's also active obstruction. That's the only thing I'll say. And you've talked to these fossil fuel guys, and I'm sure they all sound like they're really good people. And then the second thing I would say, which is related to Marshall, where he says, find the people with the right moral compass. Well, I mean, everybody in this thinks they've got the right core moral compass. The people who say, don't ever do don't ever, no, I mean, you talk to them and they'll tell you, I'm a good person. I go, I take care of my kids. So, I mean, I really think that the idea of finding the guy with the moral purpose is really finding the guy with the moral purpose that agrees with your moral purpose. Now, I mean, and you can respond to that, Marshall, but that's what I was going to say.
My response to that is pretty straightforward. I've been at this close to 20 years. And what I can tell you right now is we've run into every aspect of what you're talking about. And people that claim they have the right moral compass but don't, it's pretty easy to determine that. I'll give you an example. We're cleaning up Ogoni land in the River Niger Delta. And the Ogoni land's the size of the United Kingdom. Shell Oil, who claimed that they were doing the right thing, drilled for oil in Ogoni land. Now, when I was 16, my father sent me to an oil rig in Texas. I know what this is about. These people have 5 centimeters to 40 meters deep of oil throughout all of Ogoni land, the size of the United Kingdom. How is that possible? That's a right moral compass? I don't think so. I judge people by their behavior, not by what they say, but by behavior. And by the way, what happened to Shell Oil, Royal Dutch Shell? It moved from the Netherlands to the UK after Brexit because it tried to get out of Dodge so they wouldn't get sued for all the greenwashing they did. Now, there are tools to prevent greenwashing. There are tools to prevent redwashing, if you know what that is. That's what we engage in. I'm suggesting that we come together, as Glenn has suggested, and we put together a game plan. We're not all going to agree on everything, Gregory. And you're right. Maybe there's certain things that you want to do that I don't want to do, or vice versa. But at the point of having a clear discussion with people who do have the right moral compass and can demonstrate it is what's key. I've been on this planet a long time, and my father taught me this. There's always bad actors. You have to understand the psychology and how to expose them. We do that with our teams because we've engaged with people that told us one thing and did another. I've been patent trolled. I've done everything. We have developed risk mitigation tools. That's part of the risk mitigation tools that allow us to do that. And I'm more than happy to share those tools with these people on this call so that we're protected and at the same time can move forward with a positive. Think of it like what my father experienced during World War II. He had to keep things secret, but at the same time, he had to work with everybody. So he had a special team called Special Devices. That's what they did. And that's how they operated. It's like you're in a war. The war could be with other people. The war could be with the climate. The war is the war. The threat is the threat. You need to take an ability to think out of the box and ask that question, what do we need to know to succeed? And I'm willing to ask that question with Gregory, with Glenn, with Robert, with Rob, and all the Roberts and the Rons and everybody on this call so that we collaborate in a way that we at least get some results.
Yeah, we need to get this conversation just focused and happening regularly. And so thanks very much, Marshall. That's really good points. I'm keen to hear from Hans van der Loo if Hans, if you've got any comments on this discussion. You've made a few comments in the chat. If you'd like to unmute, thank you.
Yeah, thank you, Robert. Well, of course, I have worked for Shell, and it is true that some oil companies have behaved despicably. All oil companies knew already that CO2 contributes to global warming. That's known by scientists since Arthur Santa Arrhenius discovered that in the late 19th century. All the R&D departments of all the oil companies knew that, but the way oil companies acted differed greatly. ExxonMobil, just calling a name, several CEOs have actually threatened their own R&D people. If you ever talk about this publicly, you lose your job. That's one extreme. Then they had other companies, mostly American companies, who funded think tanks that became merchants of doubt to spread, no, CO2 is not contributing. But I was actually quite taken aback by the comments, the very unnuanced comments by Robert Chris just now, who put all companies on the line. I have represented Shell in Brussels, and we have actively contributed to giving CO2 a price. We were in favor of that. I fought the oil industry because we were in favor of that. We worked on CCS legislation to make it affordable. And most of all, I would like to actually put it in the comments. In the late 80s, Shell actually made a documentary called Climate of Concern, which was a warning about the unbridled growth in CO2 emissions. And that was shared with all the governments in the world. Now, in 1992, and the people on this call all know that, we agreed three things. We agreed to UNFCCC, we agreed to COP process with COP1 in 1995, and we agreed to reduce CO2 emissions, which then were 20 gigatons per year. In 2090, they were 40 gigatons. I'm sorry, gentlemen, that is not reduction, that is a doubling. And that was in spite of the warning. So to put the guilt with the oil industry, to some extent, that's all right. To put them all in the same way is just very, very lack of nuance. Robert, please take that on. I do not want to hear this again. If I hear Shell bashing again, I will no longer participate in this group, because then you lack from respect from facts. What we have to do, and I've been a STEM ambassador, STEM for science, technology, engineering, mathematics, for 20 years. I've established 65 regional, national, and pan-European STEM platforms to foster systemic thinking. And if I come to a meeting like this and I see such a lack of systemic thinking, then I have to wonder whether I'm wasting my time. So the two things that we need to do is think systemically and act with stempathy. So there has been too much focus on research only. You cannot even do this. The Montreal Agreement, you cannot start putting things in the atmosphere. You get court cases. So there needs to be much more. Those people that have professors in front of their name, you are suffering from the ivory tower syndrome. You know a lot. You perhaps are right. But there is no value in this world in being right. The only currency is to be seen to be right and to be accepted to be right. That's the only currency there is. 10 years ago, after Brexit, since somebody mentioned that, we issued an idea which is called Very Media. So if you want to look, Very is like VERI and then media.org, I believe, which was a way that we could have a plugin on all PCs, iPads, and mobile phones sold, at least in Europe. And since Europe is the soft power in the world as far as legislation is concerned, it would probably be picked up by other legislative constructs as well. And what it would do, it would actually triangulate anything that anyone would put on the internet and triangulate that with the criteria that are taught at all schools of good journalism anywhere in Europe. So that means named sources, not somebody said, no, named sources, countervailing view, to the extent possible, correct facts, etc., etc., etc. So just those criteria. If you would want to say at the end, and therefore I think that Donald J. Trump is a good president, that is allowed. But if you would meet all the criteria for good, sound journalism, that logic could never be in the article. The European Commission was not interested, and they said to us, well, this might be good for media literacy training. And I explained to them, you do not understand why we did this. Media literacy training is a good thing to give to small kids. Actually, quite a number of comments that were made in this conference would not have been made if people had had that media training and learned a little bit better how to read what is all out in the media. And democracy has suffered enormously, particularly in Europe, but also in the rest. I think that also Donald J. Trump would not have had a chance if people would be better informed. In Europe, we see a strong pull towards the extreme right. We may get an extreme right president in France. Marine Le Pen, the AfD, which is the Alternative für Deutschland, is a kind of a Nazi party. They may win there as well. All because we find it normal to have traffic signs along physical roads, but virtual roads, no traffic signs needed. That is plain dumb. If we let the Silicon Valley boys pour out shit over the people, then this is what we get. So it's very simple. A democracy is a dictatorship of the currently living. And already in the year 1300, that is 192 years before Columbus discovered America, of course it was there already, the convention of Iroquois tribes had already the wisdom that when they would take a great decision like damming a river or deforesting a hill, that they would come together and try to reason 7 generations in advance. You can Google it, 7-generation principle. They try to take that into account. Now, I feel very privileged that I've actually met personally Gro Harlem Brundtland. Actually, Brundtland is the name of her husband, Arve Brundtland, who died in May last year. But Mrs. Brundtland gave the very best definition of sustainability that there is, and that is that every generation is entitled to look after its own needs, which gets completely wrongly interpreted by many people who think that that means boundarylessness and we can do whatever we like. No, that is wrong, because the second sentence is we are allowed to do that within the set of criteria that future generations will be able to look after their needs as well. So I'm actually pleading in Europe that we abolish the Senates, the first chamber, because they technically, in the old legislative system from the Napoleonic Code, they should verify the judicial correctness of laws. But they now start meddling about the content of the law. If that's what they want to do, they should get elected as an MP.
And so I just need to interrupt because we're coming to the end of our time. And
I hope my point is clear.
It's
if
wonderful
this
to hear
discussion
from.
will not get more nuanced, I will not participate anymore.
Can I just respond to Hans, because I think he made a good point, and I'd like to tell you one thing. Shell Oil Company, by the way, did put up $6 billion to clean up Ogoniland. So it's not a black and white situation. And Hans, I like what your thoughts are, and I would hope, this is my hope. Obviously, I can't tell anybody what to do, but I hope that you would stay engaged, because I think your point of view is worthy, and your recognition of what's going on in Europe is important. And I like your thought process. I don't agree with everything, like you wouldn't agree with everything that I say. But I think as long as we keep an open mind and we work together, as my father said, what do we need to know together to collaborate and succeed? Then we will get somewhere. And I think that's the point you're actually making. So
No, you're
I
right.
hope
You're
you
right, Marshall.
I hope you stay engaged. That's all I ask.
Okay. Just 2 more points. One is very brief one, Robert. On subsidies, check the subsidies. The bulk of the subsidies go to users. That's industries to stay competitive. And they go to consumers to keep the electorate happy. When I transferred from Japan to the Philippines, I arrived there, and in the 12 preceding years, the pump price had never changed. That was government policy, because consumers should not pay for the full price. That is not realistic. But the biggest problem, and I, by the way, I'm an economist by training, the biggest error in the fossil industry is that fossil is priced based on the cost of extraction, not the cost of pollution, except there where the CO2 pricing, and certainly not the cost of creation. It's not included. Now, I invite you all.
Hans, we've run out of time. So
try to go to your favorite car dealer on Saturday and try to get a new car, just showing the bus ticket that you came to extract it from the showroom, and then see whether you get the keys or not.
It's wonderful to have your contribution, Hans. Thank you. I'd like to give Glenn a final word.
Oh, yeah. As the next step, I think it'd be interesting to have, let's say, a meeting with parties of the willing that work on putting together a climate plan of some kind. And they'd have to think about deliverables. What do they want to produce? And I don't know how many people are interested in this, but I'm certainly available. It may be a small group.
Yeah, we can put it out there on the HPAC email list and encourage people to participate separately from these fortnightly meetings.
Right, and then we can see where it goes. And also, another issue is communication. If there are, let's say, some documents that describe something, another question is how do you want to communicate that? And then another question is ask. Is there any asks for moving money? I don't know where it's coming from or where it's going or what it's doing, but that's something that could be talked about as well.
Okay, well, thank you very much, Glenn, for your presentation. Thank you, everybody, for your participation, and we look forward to following up on this discussion. Okay, bye bye.
Thank you very much.
Thank you.